Now, all we're doing is we're translating this 5 to the right and 1 up. All right? Now, several ways of doing it. If you want to, you could actually graph it, highlight the graph if you want with the color. Yeah, we've done this before. And then we circle it, and we want to move it 5 units to the right. So 1, 2, 3, 4, 5, and up 1. That's the easiest way to do that. All right? So we would label it now. This is referred to as T prime. This is G prime. And this is B prime. All right? It's called the image and the pre-image. All right? And to me, it's kind of backwards. All right? The original, which kind of makes sense, but the original is the what? The pre-image is what they say. And this is the image. All right? So if you kind of understand what I mean, it kind of looks like it's backwards. All right? To me, the original is the image. But whatever. I'm not going to argue about it. All right? That's what they say it is. Pre-image and image. All right? Now, essentially what you're doing here, and you might see this in another geometry book, all right, it would be like this. 5, comma, 1. That's kind of the translation. All right, does everybody see that? That just means what? Move the x 5 and the y what? 1. Another geometry book, it will say this. The translation is x plus 5, comma, y plus 1. All right. Does everybody see that? All right. Again, I've seen it in all different types. That's why I say you just got to consider the source that you're looking at. How do they want it? All right. We're just going to graph it. I'm not going to ask you to, you know. All right. Does anybody have any questions with the translation? All right. That makes sense. On every single one of these, if, for example, number 3, translating it down 3 units, all right, we just move the shape down 3. So U, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And then from there, you can graph it. And then you would just label them appropriately. X prime, U prime, and Q prime. Translations, everybody agrees, simple, right? Very easy. All right, that's why I skip it for the most part. All right. Now, if we wanted to look at this over here, all you have to do is say, what did I do to K prime? I went to the right, how many? And down what? Down 1. All right. So 2, comma, negative 1. All right. And like I said, some books write x plus 2, y minus 1. Some actually do this also, guys. They write it like this. All right. So lots of different ways. Because that looks like an ordered pair, right? So if they write it with different notation as far as the looks. Okay. Now, again, let's just flip down to the harder stuff now. All right. Those are the solutions. All right. Now, here's where I need your attention. All right. And I'm not going to start at the 180. I'm going to start at the rotating counterclockwise 90 degrees. All right. And again, for me, like I said, there's rules for everything. All right. And to me, it just never made sense to try to memorize these 4 rules. All right. So we're going to revolve around the origin. All right. So we're going to revolve around the origin. What I'm going to do is I'm going to show you for question number 3. Since this is the origin, I'm going to draw from that right there. Now, it'd probably be better if you just pay attention for a second. All right. And then it might soak in exactly what I'm doing. All right. So I'm going to rotate something 90 degrees. Now I'm going to rotate it counterclockwise. Right. So I'm going to ask you, if I rotate that 90 degrees counterclockwise, what quadrant am I going to end up in? Quadrant what? 4, right?
Yeah.
That would be, right, counterclockwise. Again, I'm like you. I have to look at the clock and say, okay, this way is the way the clock goes, so counterclockwise is the other direction. Right? So that's what they mean. So does everybody agree it would be in quadrant what? 4, right? Now, if you move something 9 degrees and it's in the 3rd quadrant, it's going to either go to the 2nd or to the what? Or to the 4th. If you rotate something 180 degrees and it's in the 3rd quadrant, it's going to go in the what? It's going to go in the 1st. So now, please, I promise you it's much easier to listen to what I'm saying. All right? Honestly, I don't even want you writing down the rules, because I am sure what I'm saying is more important than remembering the rules. All right? But if you don't understand why rotating something 9 degrees is going to put it in the 4th quadrant, we've got an issue. All right? Now, what I want to do is, I'm now going to take this right here. I'm going to change color. Come on and watch what I'm doing. And now, you're going to see my actual physical rotation. Come on, Chancellor. Look up. I'm rotating it 9 degrees. Come on, guys. I promise you, you're going to go, this is the easiest thing ever. I'm going to rotate it 9 degrees. So when I rotate it 9 degrees, to me, that looks about 9 degrees. Does anybody have any issue with that? Does anybody have any questions with this? Does everybody see that's 9 degrees, right? I mean, it looks like 9 degrees. It may not be exactly 90, right? But it kind of looks 90, right? So this right here is 9 degrees. Now, how do I know those lines are perpendicular? The slopes are what? Negative reciprocals. The slopes are negative reciprocals. Right? So if lines are perpendicular, their slopes are negative reciprocals. All right? So let's look here. This slope of the purple, so the slope of the purple would be up to and over 3. Everybody agree with that? All right? Now, those coordinates of x are what? -3, -2. You agree with that? Everybody agree with that? What are the coordinates of this point right here? 2, -3. Everybody see that? Right? The slope, he's correct, would have been -3/2. -3 represents the y value. Do you agree with that? So that's why the y value is -3 and the x value is +2. So all I'm trying to do is to remind you, when something is perpendicular, the slopes are negative reciprocal. Remember with me. So when you do the reciprocal, you change the x and y, right? And you make one of them what? Negative. Remember with me. All right? Now again, I went from quadrant 3 to quadrant 4. So in quadrant 4, which one is negative? The y value. And the x value is what? That's how I knew what the signs were. Remember with me on that. Let's say for something crazy, I decided to go the other direction. If I go the other direction, then this would be 90 degrees. Does everybody agree with that? And look right here. This is still 9 degrees. Do you agree with that? So what would the coordinate be now? -2, 3. Everybody see that? So that's a rotation of what? 9 degrees, but that would be what? Clockwise. All right? Now, again, I'm going to say one more time, then I'm going to let you ask me a question. Whenever you rotate something 9 degrees, what do you do to x and y? You switch. That's all. And then I tell kids, you've got to know what quadrant it goes in. And once you know what quadrant it goes in, that tells you what the value of the signs are. Is everybody hearing me on that? All right? So any 90-degree rotation is just a switch. That's all. All right? And then you put it in the right quadrant. That's how I teach kids how to make a rotation of 9 degrees. All right, what? You'd move it to the first or to the third, depending upon which direction. If let me get to that. All right, let's listen one. I promise you, we'll get to everything. There's a couple examples. It's very easy. That's why I'm saying it's more important to listen to what I'm saying than actually doing the problem. It really is. All right. So now I'm still moving this counterclockwise. All right. So now what I'm going to do is I'm going to go back now and I'm going to ask you. I'm going to get rid of this information here. All right, because it's kind of hard to see. All right. But this became down here. This became x prime. Is everybody with me on this? So now, n. All right. What are the coordinates of n? Somebody tell me. What is it? -5, -4. Does anybody agree with that? So now I'm going to, if it's in quadrant 3, it's got to go to quadrant 4. Right? So let's switch the signs, and it becomes a 4 and a 5, correct? Now, I put 4, 5 down, and then I say, well, I'm in quadrant 4, so the answer is really 4 what? -5. So now everybody graph 4, -5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Everybody good with that? All right, now we can connect those. All right, and that would be what? N prime. Now, B, what are the coordinates of B? 4, what?
4 left.
No, I'm asking you, what are the coordinates? -4, 1. So that's in what quadrant? 2. So I'm going to move it to quadrant 3. Then move it to quadrant 3. Wow. Let's go back to, I know. I know 5th grade was a long time ago. All right. 1, 2, 3, 4. Here we go. All right. So now it's in quadrant 2, and I'm going to move it to what quadrant? 3. So I reverse. It becomes what? 1, 4, right? But it would be what? -1, -4. Very good. -1, -4. And we would call that what? B prime. All right. And now we're going to measure from here to here and from here to here. Anybody have any issues with that? Because from 2, if I move something 9 degrees, it has to be in quadrant 3. Well, okay, so those of you guys who don't know this, all right, this is like 0 degrees here. Up here, this would be what? 90 degrees. This would be 180 degrees. This would be 270 degrees. And this technically is 360 degrees, if you didn't know that. So if you're between 90 and 180, come on now, and you add 90 to something between 90 and 180, it's going to end up between what? 180 and 270. How do I know that? Because what's 90 plus 90? 180. What's 180 plus 90? 270. All right? So same thing if I'm quadrant 1, if I'm between 0 and 90 degrees and I add 90, it's got to be somewhere between 90 and 180. Or you can just remember it this way. If you're in quadrant 1 and you add 90, you're going to be in quadrant 2. If you're in quadrant 2, you're going to be in quadrant 3. If you're in quadrant 3, it's going to move to quadrant 4. If you're in quadrant 4, it's going to move to quadrant 1. Everybody okay with that explanation? Everybody good? Okay, so now, to me now, on a standardized test, here's what I'm trying to tell you. Now, this is what's worth listening to. When I first did this, that to me, I'm not looking at that going, obviously that's a 90-degree rotation. Everybody see that? I mean, I can't look at that and say, obviously that's a 90-degree rotation. Does anybody else see that? Now, believe it or not, some people have the ability to look at that and say, yeah, that's a 90-degree rotation. I'm not one of those. But I have been able to see that it is 90-degree rotation. How do I know it's a 90-degree rotation? So look right here again. This is where we come up with how I know it's a 90-degree rotation. So look here, please. If you draw from the origin and you draw to B prime, now you should be able to see that's a what? That's a right angle, right? The same thing. If I change it, all right, you should be able to say from here to here and then to X prime, now you're noticing a what? A right angle, all right? Then last one, from here to N, and then that's also a what? You with me? So to me, visually, I can't look at rotations and say, oh, obviously that's 90 degrees. All right? But if I draw it out like this, I can clearly see those are 90-degree angles. All right? Now, does everybody see what I'm saying on that? To me, I think that's kind of easy. If you remember, perpendicular is what? The negative reciprocal, which just means switch the x and y. So whenever you rotate something 90 degrees, you do what? Switch the x and y. All right? Now, for a rotation of 180, we're going to switch the x and y, and then that's 90 degrees, and then we're going to switch the x and y because we're going to add another 90, which means when you rotate something 180 degrees, it stays the same. Exactly. That's what that means. Except, what happens to the signs? The opposites. Why are they the opposites? Because if you're in quadrant 1 and you move to quadrant 3, both signs in quadrant 3 are what? Negative, but both of them in quadrant 1 were. And if I'm in quadrant 2, it's negative positive. And if I move it to quadrant 4, it's now what? There you go. To me, there's rules for all of that. All right? And if you look up the rules for the translations, you look at it and go, that's just ridiculous. There's no way to remember all that. All right? So you have to remember, 180-degree rotation is rotating 90 degrees twice, which means you switch x and y, and then you switch x and y, which means that you're back to where you started. All right? The only thing that changes is the sign. All right? So now, let's look back at the first one. So F. So the coordinates for F, somebody tell me what the coordinates of F are. Negative 4, 2. So if I rotate that 180 degrees, it would be what? 4, negative 2. It would be 4, negative 2. So now I count out 4, 1, 2, 3, 4, negative 2, and I put an F prime. And then what's P? P is, what are the coordinates for P? 1, comma, 4, right? So then, if I rotate that, 100, negative 1, negative 4. And then put P prime. And then N, what is N? Negative 1, negative 2. Thank you, Chancellor. So what is it going to be? 1, 2. No, I'm just surprised. Chancellor doesn't usually talk. He doesn't usually pay attention. So I'm proud of him today. Yeah. And then K would be what? 3, 0. So 180 would be, yes. And that was kind of the easy one because if you're on an axis, it's just going to move over to the other side. Does everybody see that, right? Isn't that easy? Now, let's connect those dots. I know, that's another reason why I hated doing this, because this isn't really math. It's like drawing. But some people like to draw, so I decided to add that in, because I'm so nice. All right? Now, to me, once again, that looks like not a 180-degree rotation to me. It doesn't look like it to me. Right? However, again, and this is what helps out, I think, from the origin to 1, 4, and then if you change it and watch, and then you rotate it, that's 180 degrees. Isn't that nice? All right, so again, I can't really visually see the 180-degree rotation. What it is, I think Notability does an amazing job allowing you to rotate it 180 degrees to see what it is. All right, is everybody with me on this? Quickly. Yes, of course.
They're switched.
Yes.
Yeah.
Exactly. Good observation. I'm proud of you.
When it goes in a square, you will do it.
There you go. Good job. All right. Very proud of you, Reagan. All right, here we go. Now, again, listen, I want to go ahead and jump. Hurry up, because you're going to miss the next lesson. All right. Now, on the next lesson, let's scroll down to the reflections. Now, again, I just think reflections are super easy. I think you guys will see that it's super easy also. So I'm going to reflect across y equals -2. So what we have to do is we have to find y equals -2. So this right here is y equals -2. Does everybody see that? Yeah. So basically all you're doing is you're counting to that line and then reflecting it over. All right? So in this case, watch, Q, right, is how many units from the line? 2. So I've got to be what? 2 units above the line. So this point right here is Q prime. Everybody happy about that? Then I prime is nice because it's on the reflection, so it just stays the same. E prime would be right here. And then Z, it looks like 1, 2, 3, 1, 2, 3. So that's Z prime. All right. Now I'm going to go ahead and erase this line right here because I don't want you to be confused by that. All right. So we have here. We're now going to draw from here to here, from here to here, from here to here, from here to here. Now, to me, I can clearly see, listen, I can clearly see that reflection. Does everybody agree with that? Quickly, come on.
So it's like, okay, so with the eye, instead of moving it out since it's on the reflection.
Yeah, there's 0 units away. It's 0, right, it's 0 units away, right? So it's that point, all right? Does anybody else have any questions with that? Anybody else? Anybody else? Anybody else? All right. So now what we're going to do is number 3, reflecting across the line y equals -x, which is the hardest one. All right. But not for us because we are brilliant. So we first would, of course, have to graph the line y equals -x. All right. We have to graph the line y equals -x. All right. So the y-intercept is 0, and you go down 1 over 1. Right? Or you could say all of those coordinates on that line are opposite points. That's what that means. All right, is everybody happy with that explanation for y equals -x? All right, now to rotate it here, all right, normally you're rotating something perpendicular. All right, when you rotate something about y equals or x equals, you're measuring vertically or you're measuring horizontally. In this case, you're measuring on the diagonal. And let me explain why. Because when you measure, you always, the shortest distance is the perpendicular distance. All right? So that is 1 diagonal away. Does everybody agree with that? So I'm going to measure what? 1 diagonal away on the other side. So this point right here would be considered what? A prime. And then J is what? Half. So J prime would be over here. And then T is what? 1.5. So T prime would be right here. And then the other one I'm looking at is S. How far away is S? How many?
3. Yeah.
Am I counting 3 or 4, guys?
Sorry.
3. So now we're counting 3. 1, 2, 3. And this point right here is S prime. All right. And now from there, here, 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 and here. Now, to me, if I erase, I can kind of see that reflection. Everybody see how easy that is? All right. Now, if you want to know the rule, look at J. Point J was 1, 2, 3, 4. And then what? 4, negative 3. And then J prime is what? 3. There's no way I'm remembering that. Let me see what I'm getting at. You switch them and negate one. I don't even know which one to negate. All right? You change the signs, right? So in this case, you just do what? Switch and change the signs. That would be the rule. All right? If you're going to rotate around x, y equals x, you just switch the signs. All right? So again, to me, it's not about remembering there's like 10 rules or 12 rules. It's about understanding that you're measuring perpendicular to a line. All right? And then there are patterns. All right? There are patterns for everything, but there's too many patterns to remember. All right? Does anybody have any questions with that? All right? So just one other quick one, since I have time. X equals negative 3, right? So I'm graphing x equals negative 3. Here is x equals negative 3. Everybody see that? Go ahead. What's the same as y equals negative x? No, because that's positive.
Oh, yeah.
True. So this one on number 6, that's what you're asking me. This way. That's y equals x. You with me? It doesn't matter if you say x equals y, or, you know what I mean? All right. I believe that's a pretty good lesson for today. All right. And I also believe that most of you guys are pretty good. On your test, I'm going to have a rotation, a reflection, and a translation. 3 questions. That's it. All right. And the rest is going to be on triangles. So here's what I'm telling you guys. So please do me a favor. This to me, I don't like to draw. I'm not interested in this at all. All right. But what I'm saying is, you have to do it until you understand it, until it makes sense. All right. The translations, that's no big deal whatsoever. I could teach that to the 5th graders. They would understand that. So that's not the issue. The rotations are the ones that are more difficult for kids, that they're putting more on standardized tests. So I need you to make sure you understand that. And the reflections aren't very difficult if you understand how to draw the lines appropriately. All right. So again, what I'm doing is make sure you understand that. All right. Because like I said, 3 questions on the test, and you're going to have to draw them out. All right. A translation, a reflection, a rotation. I'm not going to tell you which one. All right, but there'll be something. All right. And then everything else will be regarding the proofs and the triangles. Did I add to your Google Classroom the review yet?
No.
All right, so I'm going to do that now. I think that's kind of important. So here's what your job is.
Quiz Thursday.
Yeah, your quiz is Thursday, but listen to me. Thursday is kind of a shorter day because we have Eucharist, and I'm not sure if I want to make it shorter test because it's kind of long. There's going to be a couple proofs. I may make it on Friday, or listen, I may just shorten the test. Right? I haven't really decided because we had the hurricane, and the hurricane already put me way behind. All right, so I don't really feel like I can just take another day. All right, so I'm giving you kind of, you know, if we have a test on Thursday, that means Tuesday, Wednesday study, and Thursday is the test. All right, I was going to make the review just one day and give you a test, but there's a lot. All right, and I want you to do well, so I'm going to still probably give the test on Thursday, or I'm just going to shorten the test a bit, because I think there should be 4 or 5 proofs, and there should be the triangle information and a couple of the drawings. All right. So again, I'm going to add, what I want you to do is do as much as this. What I'm trying to say is do as much as this as you need to do to make sure you understand it. Now, some of you want to make an A. That means do it what? Do it all. That's what you want to do. You want to do it all. If you're not making an A, you should do it all. All right? then while you're continuing to work, I'm going to add the review. And on the review, because last year I didn't teach this, it's not on the review, but this, I'm going to remind you, is going to be on the test. I just didn't put it on the review. Everybody with me? All right.